we will just want to make a quick video on the difference between structured analysis versus object-oriented analysis. So we will we will do this using a car as an example. So we'll compare the two. Let's assume we want to model a car. Let's keep it very simple. So we'll have two ways by which we can do it. One is a structured way, the other one is the object-oriented way. So one of the processes in a car is to start the car. So we need a process called start. Okay, and when the car is started, we say the car can be in a ready state or it can be in a stop state, in a ready but stop state. It's ready to move but in a stop state. So we need to be able to know which state the car is. Yeah, so we need to be able to, so we can treat this the states as some data items that you need to have control over. Now the process could be to drive. So when you drive, when you have a process like to drive the car, then it can change the state of any of the data objects. It could be, we can say the car is in a ready state, but not in a stop state. But it could, and on top of it, we can say it's in a run state. We can again store more values corresponding to the state of the car. Another process could be apply brakes. So when a brake is applied, the car can move from some other state to some other state. For example, it can be in a run state, and it can be in a ready state, or it can be in a stop state. So what we can see from all this is that potentially any process can change the state of any, can change any state. So when such a thing happens in software, we can think of this as a hard problem to maintain because we don't know which process has caused the change. Now let's compare that with respect to object-oriented analysis. Here we can think of the car as being composed of brakes and engine. Okay, so we can think of a brake object and an engine object. And we can say a brake has its own state or states and its own process, and so the engine will have, so brake will have its own state and process, and engine will have its own state and process too. Now, if you want to start the car, the start process will be a process within the engine, and if you want to brake the car, then the brake process will be within the brakes object. So these two will have different states and different processes. Now, if the two objects need to communicate, if the two objects need to control each other, they need to request the process of the other object to operate. They cannot control it directly. They'll have to ask the other process to other object to request the other object's process to be executed. Now, this is a much better control because then object, in case now we say if the brake object does not operate properly, we know what to fix. We know that it has the brake that needs to be fixed, not the engine. So in summary, maintenance in object-oriented analysis by object-oriented approach becomes a lot more cheaper and much more easier because we are constraining the processes to work on appropriate states in that object, so they cannot be working on any or every object, every process. So that's it. I just want to make it simple. Hope this is clear.